Hi, I'm Asal Aminian. Welcome to the first video in the Statistical Distributions playlist. In this video, we're going to look at one of the most fundamental concepts in statistics, the statistical distribution. Distributions describe the way our data are spread out, and they are the foundation of data analysis. Imagine we measure the heights of many people. We measure each person's height and place each number into an interval or bin. When we put many measurements into these bins, we get a histogram. Most of the measurements belong to people whose height are between 140 and 160. People shorter than 140 are relatively rare. People taller than 180 are rare as well. In other words, if we choose one person randomly, there is a high chance that their height is between 140 and 160. The histogram shows us how likely it is to see someone very tall, very short, or close to the average. Now, what happens if we make the bins smaller? Suppose each bin is half as wide as before. In this case, we place the data into smaller bins. And we still see that most measurements fall between 140 and 160. But this time, we can say more precisely that 1/3 of the people are between 160 and 165. By measuring more people and using smaller bins, we get a more accurate and reliable estimate of the distribution of heights. We can draw a curve as an approximation of the histogram. This curve gives us the same kind of information that the histogram gives us. The curve has several advantages over the histogram. First, even with many measurements, some bins may still be empty. Does that mean no one with that height can ever exist? Well, of course not. With a curve, we can calculate the probability for that interval as well. Second, the curve is not limited by the width of the bins. For example, if we want to know the probability of a height between, let's say, 151 and 153, we can use integration to find that probability accurately, without having to round the value to the nearest bin. Finally, if we do not have enough time or budget to collect a large amount of data, an approximate curve built from the mean and the standard deviation of the available data is usually enough. So using a curve can save us a lot of time and costs. The highest point of the curve shows us the region where outcomes are most likely to occur. The lower parts show regions with lower probability. We have been talking about how height measurements are distributed. But there are many types of distributions with many interesting shapes, and we will talk about them in the future videos. So more precisely, a statistical distribution means the way data are spread across possible values. Which data values occur more often? Which values occur less often? Are the data clustered around the central value, or are they widely spread out? So a distribution is a function that describes the probability or frequency of different values happening. For example, in this histogram, you can see the distribution of the daily return of a real stock. Most values are concentrated around 1%, meaning daily changes are usually small. In contrast, values further from zero, whether negative or positive, happen less often. But they are very important because these outlying points represent large fluctuations and the real risk of the asset. Overall, this shape helps us understand how daily gains and losses are distributed and the volatility pattern of the asset. To fully describe a distribution, the central value and the spread are not enough. The structure of a distribution is usually described by three key parameters. Location determines where the distribution sits on the value axis. In financial data, this value is usually the expected return. Scale represents how spread out the data are. and it is measured using the standard deviation. In finance, this concept is directly related to volatility risk. The shape of a distribution can be described using two important ideas: skewness and kurtosis. Skewness tells us whether the distribution leans more to one side. In this chart, the distribution is positively skewed. Most values are close to zero, but the tail stretches far to the right. That means large positive values are possible, even if they are not common. Kurtosis tells us how heavy the tails of the distribution are. Heavy tails mean that extreme values are more likely than they would be in a normal distribution. This is especially important in financial data because large market moves, both gains and losses, can happen more often than simple models might suggest. Thank you for watching the video till the end. If you enjoyed this video, please be sure to like it and subscribe to the channel so we can continue learning the concepts related to statistical distributions in a simple way.